And welcome back to the lab, robots. This is going to be a part 2 of building an Ubuntu AI-based server. If you haven't seen part 1, I suggest you go do that. But to recap, we got all of that hardware together, built the machine up, have it hanging out in pieces for now. Now that we know everything works and we have Ubuntu Server 24.04 installed on that machine, let's go ahead and continue on with what is normally considered bootstrapping. So we're going to bootstrap this node, and basically what that means is we're going to go through and install all the base software that we need on this machine to go ahead and continue on down the road of using, say, LocalAI or Comfy UI or anything else that is going to want to use your GPUs, along with basically using Docker to access those GPUs. So first off, the one thing that I want to do is I want to push my SSH key to that server so that I don't have to constantly type in my password for the user when we're going back and forth. It's just a local server. I suggest you guys do the same. You can generate an SSH key on your machine or an SSH identity, and then you can push it to that server so you don't have to type the password in all the time. I will say normally this bootstrapping process is handled by something like Terraform or Ansible or Cloud Init, or depending on how you're setting up your nodes, especially if you're going to treat your nodes like cattle and constantly be rebuilding them. In this case, we're just going to do a single node, so we're not going to get into Kubernetes in this series just yet. But what we are going to do is set this up just like it was going to be a single AI server based in my house on Ubuntu that can run different Docker containers, and we can do some development on remotely. So the first thing, like I said, is we want to push my SSH key. So I'm going to use SSH copy ID to do that. SSH copy ID, and the username that we used was Ubuntu, and that's the IP address that I had assigned the machine. Your IP address might be different. It's going to ask you to type in the password you set on that remote machine at least once. Now you should just simply be able to do an SSH Ubuntu at the address that you had set, and it should log you right in. Okay, we can see that we're logged in, running 24.04.1. We can see that there's already some updates available, so one of the first things I always like to do and get it out of the way is do a sudo apt get update. Type in your sudo password now that you're on that machine. You can also add the Ubuntu user to the sudoers so that you don't have to continuously type in the sudo password also. I don't recommend doing that on any server in any type of production level environment, but if you're just building a server for inside your personal network, go ahead and do it. And in fact, we'll just go ahead and show you guys how to do that while we're here. Do a sudo usermod -a capital G sudo and then the username, which is Ubuntu. Now let's go ahead and do a sudo apt get upgrade -y and get all of those updates applied. And we can see it installing all of the different updates that were available. We can get this out of our way, although we're still going to install a bunch of other things, but it's always good to bring everything fully up to date. Okay, that's done. The next thing that we want to do is basically go ahead and install the hardware enablement kit for Ubuntu 24.04. What that does is it gives you selection of a much newer drivers and a kernel to use underneath. So what you do is a sudo apt install -- install recommends Linux generic HWE, and then whatever version of Ubuntu you're on. In our case, it's 24.04. Yes, we want to install it. All right. Next, let's go ahead and get a few other things out of the way. And I'm going to start copying and pasting out of my notes so you guys don't have to see it. This is going to sudo apt install the apt transport HTTPS that allows you to install packages over HTTPS. Do the CA certificates and software properties common. Let's just go ahead and get those out of the way. And then this is a big list of tools I like to have on machines right off the bat, which is basically the build essentials, which is meant for developers and includes make and compilers and stuff like that. Then we install wget, curl, git, unzip, zip, libssl dev, and a few other libraries, cmake, python 3, python 3 pip, python 3 virtual environment, and dev htop, and NFS common, which you don't need unless you're going to use NFS drives, which I'm going to use in my lab, so we're going to get that right out of the way. Now, just for the sake of it, let's go ahead and reboot the system now that we did all those updates, and we'll wait for it to come back and we'll reconnect to it. Alright, I heard it reboot in the back end. Let's go ahead and reconnect to it. There we go. We can see it's much more updated. Let's just double check that we can see our Nvidia card. We'll do an lspci, pipe it to grep, and look for Nvidia. Should get that 14060 card back that we had in there. Yes, we do. Alright, so now we can continue on. I'm going to... one thing else I like to do right off the bat is set the time zone. So we'll do a time date CTL, set time zone, and I'm in MST, so that's America, Denver. That's just nice when you're looking at logs. Make sure your time zone is set to wherever you're at. All right. I'm going to mention one thing here. If you are planning on going down the road of Kubernetes with these type of nodes, or building Kubernetes in your lab or at work or whatever, you may as well stop here and actually go and investigate the Nvidia GPU operator, which is specifically meant to run inside your Kubernetes cluster and manage your Nvidia drivers, Cuda, the container toolkit, etc. that we're about to walk through for this specific node. That is just for Kubernetes, so if you're not doing Kubernetes, don't worry about it. But if you are, I highly suggest going down this route instead of managing it all yourself on the nodes. It'll make your life a heck of a lot easier. So one of the specific things that we need to talk about is you can always come and look at NVIDIA's documentation. That's one thing that NVIDIA has over all of its competitors right now, is its documentation is quite well done, along with their drivers and software is quite well done, especially when you're talking the Linux world. So to get our main drivers, we already had some drivers installed when we first installed it, but to get everything installed, we need to walk through it because we need to install all the drivers, the container toolkit, the Cuda toolkit, and get it set up so that Docker can access those NVIDIA cards through the container toolkit. So you can come and look at their docs, read through everything that you need to read through. We're not going to read through all of it on this. I'm basically just going to go ahead and we're going to walk right through exactly what they say to do for Linux. So we're going to copy and paste their commands over here just to satisfy everything. And you could either choose to do it as a local or a network repo installation. We're going to do a network repo installation, and you can see that it's having you do a wget command to go pull depending on what your distro and arch is. So you can copy this command, but make sure that you replace this with whatever Ubuntu version that you're running and the architecture that you're running it on. So for us, that's going to be 2404, and this is an x86 Intel based machine. So we're going to go ahead and download that. And then we're basically going to install that by doing a sudo dpackage. And then the first thing we want to actually do now is install their drivers. But now that we've installed the repository, let's go ahead and do a sudo apt-get update. And then depending on whether you want to do the open kernel modules or the proprietary ones, there's your commands right there. So again, we'll just grab that. Say yes, let it go ahead and download all the CUDA drivers. Okay, and as recommended over in their instructions, we're just going to go ahead and reboot the system. And we'll come back when we hear it reboot. Okay, and now it's back to rebooted. Now that we have all the CUDA drivers installed, we should be able to do an Nvidia SMI and get it reported back that our CUDA version is 12.7. We're using driver version 5655701, and we see that single 4060 that we have put in that server for now. So that's great. Machine sees it, recognizing it. We've got a new driver and we've got a new CUDA version. Next, what we want to do is we actually want to do a sudo apt-get install CUDA Toolkit. And again, those instructions are on how to install the CUDA guide. And if we just go down to Ubuntu, they walk you through installing through the driver first. But then we're doing that same thing. We added that repo already, and then we're basically just running through and installing the CUDA toolkit. Now this downloads quite a bit of stuff, but if you're going to be working at all on this machine or using it for CUDA development or running CUDA tasks, go ahead and get this all installed. Again, part of the bootstrap process, just so it's available for me on any of my machines. Okay, and according to their docs, we'd want to reboot right here, but let's go ahead and get one more piece installed before we do that, and that is the Nvidia Container Toolkit. Now this is what's going to allow Docker or Containerd or whatever it is that you're running as your virtualization layer for Docker to be able to pass those Nvidia cards over to the containers for you. So it's quite important. So it's just a sudo apt-get install nvidia-container-toolkit. And again, go look at the Nvidia docs and you can figure it all out. This is something that the GPU operator, Nvidia GPU operator, does for you if you're using it with Kubernetes. So once you have that, and actually let's go ahead and install nvtop too. Sudo apt-get install nvtop. But now that we have the Nvidia Container Toolkit installed, one of the big things that we want to do is actually set it and configure it. So using the Nvidia-ctk command line, you can actually tell it to set either Containerd or Docker or whatever and set it as the default, and it'll write out the config for you. So if I do this command that we have here, this is basically going to be system-wide for Docker. You could also very much do it like this in a much more secure setting where you're setting it just for the local user. And you can see that we're setting the config and telling it where to put it. And if you guys want to look at that, this is the file that it's basically running out, telling Docker in our case, and you can do the same thing for Containerd, and it's basically telling it how to work it so that the Docker containers can actually access the Nvidia cards directly on your machine. So let's go ahead and do that final reboot. And we'll come back as soon as that's up, and that's basically finishing your machine off and getting it ready to run GPU powered Docker containers to run local CUDA applications. So if you wanted to develop it locally on there, and that's it. And we'll come back and go ahead and get LocalAI, and I'll walk you guys through what LocalAI is up and running. This works the same way if you wanted to use, say, Llama.cpp or Llama or whatever through a Docker container. And we'll get that up and running and run some initial tests and show you guys just how that works. Now we're rebooted and back up. What I want to do is go ahead and install one last set of tools here for Docker. Sudo apt get install docker.io. This is going to install things like Docker Compose and other Docker tools that we want to have on here. Then let's do a sudo new group docker and sudo user mod eg docker ubuntu. Let's drop out of this. Let's reconnect real quick. Alright, so now we've got Docker working just fine, which means now we can move over and talk about local AI, because that's what you're all here for, right? Is to try to get AI running on an Ubuntu server either in your home lab or someplace else. So what is local AI? Local AI is basically a wrapper for a bunch of different back-end inference engines such as Llama.cpp, VLLM, Stable Diffusion, and many, many, many more. That's one of the reasons why I like to run it, especially when we're talking about server instead of just like locally on my laptop. Locally on my laptop, I tend to use LM Studio if I'm away from the power of my home lab. But my home lab has a lot more power than my laptop does, so normally I'm using my home lab. So what is LocalAI? LocalAI is a fantastic project. I described to you guys what it is. You can come to localai.io. I support this project the best that I possibly can, which means that even I personally sponsor this project. The team that makes this has put in a lot of work into it, and it basically runs very well and mimics an OpenAI API standard for you, and also does things besides just typical inference. It does have the ability to do text-to-speech and speech-to-text, and you can do image generation. It has the ability to do distributed load where you can add workers, so multiple nodes into it, and it can handle multiple nodes that it'll distribute your AI workloads for you. I feel like you guys should check this out. It's one of my favorite projects. Again, it does use Llama.cpp under the hood for a lot of what I use it for, so this is basically wrapping up Llama.cpp. If you go to their site, they have many good docs about how to get quickly started with it, whether you're running in Docker or you want to just run it locally and build it or install it as a binary on your machine, or if you are using Homebrew on Mac OS, you can do it that way too. But we're going to concentrate on using container images or Kubernetes. So what we want to do is flip over and talk about using container images. They have a ton of different container images already pre-built on their Quay.io registry for you. So you can just pull these images. I will warn you, a lot of these are very, very big images, and not only are they big images, but some of them, like the AIO, that's all-in-one images, will also pull gigs and gigs of LLM models down from Hugging Face as soon as it starts up, which we will go through. So depending on what you're using, if you're using, say, an AMD card, they do have ROCm ones, they do have SIL available ones. Pay attention to the different ones that they offer to you and the different environments that you can. Again, they have very good instructions about how to run this. One of the big things that we want to talk about, though, right off the bat is how to run it and make sure that the models don't get downloaded every single time. So if we're going to run this through Docker, we need to set up a models directory someplace to where we can link those Docker containers too. Now, previously in the build series, you guys saw me set up a pretty awkward LVM group disk setup where we had the two SSDs and the NVMe drive set up in different ways, where one was a boot drive, one was set up to hold the home folders for the users, and then we mounted that super fast NVMe drive at /var so that Docker, Containerd, etc. could use it directly for running the containers. So when you download Docker images and stuff, they'll be stored and running off that NVMe drive rather than one of the SSD drives. So this is going to be greatly dependent on how you set up your machine and where you want those models to be constantly stored. Now remember, some of these models that you might be running are tens of gigabytes, if not hundreds of gigabytes, depending on where you're going with this, right? So you want to make sure that it's on some sort of pretty decently fast storage, or you're going to be waiting for forever for the model to load up the very first time. So with that, we actually want to make a directory on my machine under var, so I'm going to have to be sudo for this. You could do it in your home directory if that's how it's set up on your machine. Don't worry about it too much. Just make a new directory. I like to call mine LocalAI. And then inside that directory, I'm going to go ahead and create another folder that's called models. All right, so they talk about this and about caching the models path locally on your machine if you're using Docker, and they give you the exact way of doing it right here. Now, the next big thing is if you're using GPU accelerated images, then you're going to want to pull very specific images from them, and then you're going to want to pass very specific arguments over to the Docker container when you start it up. They give you examples here of how to pass the runtime of Nvidia and how to pass the GPU's alls here. See this? And some environment variables and what port they want. So this example right here is normally what I would tell you to go ahead and just grab if you're just in a hurry to get this started. To serve it as a server, what we'll really want to do is build out a Docker Compose file, in my suggestion, at least to build out a Docker Compose file that has all this stored so you can just do Docker Compose up and Docker Compose down. I will have examples for those available to you guys a little bit later, but let's just go ahead and grab this command. This is going to be for the Nvidia or Cuda cards. If you're using, say, the AMD ones, rock them. Go get the images, especially for those, but you're going to have your specific drivers, whether it's AMD or Intel, installed correctly along with whatever their container toolkits are. There is instructions on LocalAI to show you how to do that. But what we're going to do is we're going to grab this one, and we're simply going to paste this in. This is a very fast one. One of the first things we're going to change is their docs are a little bit out of date. So this is actually all the way up to 2.24.2 as of today. You can go get the list off of their website, or they have a Quay registry where you can go see exactly where it is. You can always see it like right here. So on the front page, it will tell you what the latest version is, and we'll link you over to their GitHub repo or the Quay list right here for these very specific Docker containers. And you can see there's ones for CUDA 12, CUDA 11 for SIL, all-in-one GPU, and we'll get over the all-in-one. As it is in their documentation, if you go and read it, the all-in-one includes some very specific models just to get you started with inference, with text-to-speech, with speech-to-text and image generation and embeddings all right off the bat, so that you don't have to worry about that too much. So we are actually going to just pull this one here. Actually, you know what? Let's go pull the all-in-one, because most of you, I think that's the best place for you to start, is the all-in-one images. So let's go here and I'm going to filter this. And the 242.24.2 all-in-one GPU Nvidia Cuda 12 is the one that we're going to grab off, and that's the one that we're actually going to run. So I'm just going to paste that in at the end. Now right here where it has a dash V, right? A dash V is volumes. It's passing the current directory / models over to the models on the Docker container. So what I'm actually going to do is just change this for my setup, make it match your own, and mine's going to be in var /localai /models. And the other things that you can change right here is threads. This is the amount of threads that LocalAI will use to run. So in this case, let's go ahead and set this one to 10 because this has 10 cores, 20 threads on the CPU. So if you want to, you can go ahead and max this out. I would say let's go ahead and leave a few available. And the other thing to pay attention to is where it says GPUs all. This is where you could actually control which GPUs LocalAI is going to have access to. So instead of saying all, you could say GPU 0 or 1 or 2 or 3. This is what you guys see me changing even through Kubernetes when I'm running those other tests that flip-flop through all the different, and it gives me control over what containers can access what GPUs. So just remember that. We're going to leave it on debug true. We're going to expose it on port 8080. And let's go ahead and hit enter and get this started. So it won't be able to find it locally. So it's going to start to pull it. This is gigs and gigs of data that it has to pull down just for this container. As we can see, it's 21.5 gigabytes. And then after it's done downloading this container for the first time, once it downloads this once, it'll cache it on your machine until you go to update it. But once it downloads all of this, it's also going to start up and then start downloading a bunch of models. So we're going to go ahead and let this run, and I'll fast forward it through it so you guys don't have to sit here and watch this and listen to me blab, and we'll come back when it's up and running. Okay, you can see that it finally downloaded the Docker container or Docker image itself, and now it's starting up, and you can notice that it's already pulling a few different models down from Hugging Face. This is part of the all-in-one image. If you don't want it to pre-download models, you know the ones you want to use, just don't use the all-in-one image, and then you can choose what models you want to use later on. But if you're just new to this and you're just getting started, I suggest starting with the all-in-one image that comes with a bunch of preset downloaded models for inference, for text-to-speech, for speech-to-text, and for image generation. It just gets you started up right away and gets you going with LocalAI. So let's let these go ahead and download, and we'll come back when they're all done. Okay, now that all the default models have been downloaded, you can see that it is already reporting back that LocalAI API is listening. Please connect to the endpoint for API documentation. Now, LocalAI is also running as an API endpoint, but it does have its own UI that they've been working on. So now you should be able to hit it at your IP address of your server on port 8080, and there you go. It answers right back to you, and you can see the log. So it's that easy. We're up and ready, and go ahead and do some basic inference or anything else. So this is LocalAI. Let's take a look at the UI so that you guys can see it. You can see that it's already reporting to us the 8 pre-installed models that it did for us. It's naming them GPT-4, GPT-4o. This is not actually those models. It's more like Hermes and some other models behind the scenes, but just some ones that they have chose to use as their default ones. You can see it installed some stable diffusion for us to use, a text embedding model, text-to-speech whisper is speech-to-text. So let's go ahead and take a little bit more. If you ever want to see the documentation about how to use the API endpoints, like you're using it like an OpenAI endpoint, just hit the documentation tab. It will take you over to their homepage. And then if you want to see the API docs, just click API over here on the top right hand side. And this will take you to your Swagger docs where you can see all their different endpoints that you can actually test and play with, and it shows you how to use it directly through the UI. Let's go ahead and go back. If you click over to models, now LocalAI runs their own repository of models from Hugging Face that are already tested and basically ready to go. And you can search through the different ones here and go ahead and install them directly through here. So like if we wanted to say install Mistral 7B, let's type Mistral in here, right? So here's Mistral 7B instruct. You can click the info, see it on it. It'll tell you exactly which one it's going to go out and which one it's going to go download. And then we can just click install. You can see over here on the logs, it's pulling it from Hugging Face. And it's going to go ahead and download and install that. You don't have to sit here and wait for that. It's going to do it in the back end. While it's installing Mistral 7B for us, let's go ahead and click over to its built-in chat screen. So this is here. You can again use this with like anything LLM. You can use it with like VS Code as an API endpoint. Anything that you like, you can use it as an API endpoint for chat, but it does have its own chat built in here. So I can come in here and select a model. Let's just say GPT-4 for this specific one, and we'll watch this one go. I'll say, hi, how are you? And we'll watch it load up in the background. So you can see all the logs of it loading up that model while it's still downloading Mistral 7B. So this will be the first inference that we're basically running even while it's downloading in the background. So it's taking a while to load up the model, and then we should see a response here once it's done loading up. There we go. Can you rate me a poem about AI engineers? And this is with that 4060 Ti, 16 gigs. If you've watched any or all of our reporting videos or anything where you see me getting all of those numbers that we're pulling off for like the actual leaderboard tests or for any of the graphs that we're pulling, this is where I'm getting them from, guys. I'm pulling them all from the LocalAI logs, and you can see at the very end, it's spitting out the timing of all of your requests. So this is base inference already running off the top of the bat. Let's go ahead and click back to the models and see if it still shows us that installing. Okay, it's already installed. That's awesome. Now we have a chat interface, right? Much like we had that chat interface, we also have a generate images. So you can come in here and use the base built-in stable diffusion to do that. Also, same thing, again, text to speech and audio. Select your different models. Here's text to speech. And then audio is the Whisper 1 for speech to text, which you can come in here and actually just do a talk. So let's go ahead and do this. Oh, you guys wouldn't be able to hear my computer spitting back for Whisper 1. So you guys can come in here and play with this when you're ready to do this. To get into way more advanced, the Swarm tab, this is where it's all about distributed inference. I do have other videos on this, but this is much more advanced if you're using multiple nodes to try to run inference across. But just know that that's there. Now we have that running, right? All in the background through Docker. We were seeing the logs and everything, but that's kind of annoying. It's got the logs rolling. We have to be SSH'd into that server to keep it running. So we're just going to Control C to go ahead and stop that. And the next stage of this would be for us to build this into, say, a Docker Compose file that we can just launch, or just, if you wanted to, you could rerun that command, and instead of doing a TI, you could use a D to send it in the background. So you can run Docker containers in the background. I just find that Docker Compose is much more generally easy for people to use and for bringing up multiple stacks. And we'll get into that later on because there's a lot more stuff we want to get into, say like Comfy UI, or maybe we'll get into things like FlowWise. So let's go ahead and move on, and I'll show you guys some of those examples of how to run local AI. So what we want to do now is talk about the Docker Compose. This is something I went ahead and just built a quick example for you guys. You can come see it on my GitHub at RoboTF AI Suite. I'll put the link down below. But basically what this is going to be is I will build this repo out more and more and more with different Docker Compose files for different tools as we go along in this series. But the first one that we want to look at is this Docker Compose that I made for LocalAI. This is basically the equivalent to us running that command to bring up LocalAI, but it'll do it for us in a codified way and allow us to adjust things on the fly if we need to, and also easily send it to the background. So the same thing that we ran, we're starting up a container that's called LocalAI. You'll want to adjust this platform if it's different for you. Same thing, you will want to adjust the runtime if it's different for you. This will keep the latest images. Here's some examples of the all-in-one for CPU for ROCm and for Intel. Here's your ports defined. Remember, it's going to expose port 8080 on this machine. Here's your volume mounts. I will need to adjust this to make it work on our example. But if you wanted to, this is literally going to use a models folder right at the directory. Here's some different environment variables. LocalAI has a ton, so I suggest that you actually come over to their docs, go down to the advanced usage, and then start looking at the different environment variables that they have. Some of them are necessary and needed for things that I do, so I will just whip through some of my ones that I have set on here for you guys. This is F16 that enables GPU usage. Debug will turn on all the debug logs. You can turn that off if you're not going to be using the debug logs at all. Context size, this sets the default context size for models. Your model configs can override this, and I will go into that probably in our next video when we get into advanced usage of LocalAI and how to install models and configure them and change the model settings really easily. Llama.cpp parallel, this sets it to allow parallel request and how many that it can handle. It goes hand in hand with the parallel request settings. The watchdog idle and watchdog busy, what this does is this will automatically onload your models if they're sitting there idle or if they've just been sitting there working for too long. So what this does is makes it so you don't have to restart LocalAI to, like, say, change models, and it'll just free up the memory after whatever period you have set. So the server will just be sitting there listening. If you're going to be generating images, you want to set the image path. Along with, if you're going to be uploading documents or anything like that through the chat, you can set an upload limit. The threads we discussed about, that's the threads or the number of threads that LocalAI will use to run the different processes. The models path, you could use this, and this is also going to be used in conjunction with the volumes that you mount. The Nvidia visible devices, this is specifically for Nvidia cards and if you have multiple GPUs. API keys, if you want to lock down your LocalAI instance, you can set API keys here, and then when you come to the UI or use it through the API, you will have to pass an API key to it. So that's a good way of locking down your LocalAI instance. So you can set that. Now down here, this basically is telling it it's allowed to use GPUs, and it's going to keep it running unless it is stopped. So how do we use this? even if you're not super familiar with Git or anything like that, one of the things that we installed on that machine was the package of Git. So I'm going to go ahead and clear this screen here. And what we can do is I can just go see this little green button right here, and I can grab this URL and simply type git clone and type in that URL. What that is going to do is going to take a copy of that code base and pull it down to this machine. Now, all we need to do, and I do have some basic instructions on this and inside the README file of what you need to do to get this running, but we're going to cd into that folder, and then I'm simply going to type make help. Make is another one of those things that we installed during the bootstrap process. Now you can see make help actually is going to print back a list of commands that this make file can help you with. The make file, just so you guys know, all it's doing for you is wrapping up, here let's take a look, wrapping up a bunch of different Docker Compose commands to make it easy so you don't have to remember all of these different type of commands. So you can see that we can turn on LocalAI by saying make LocalAI -up, see make and then the target. We can turn it off, we can restart it, we can exec into that pod, or LocalAI logs help. Either way. First, one of the things I tell you to do in the instructions is to go edit that file to your liking. I like to use Nano, some people like to use VI, or whatever your favorite Linux editor is, or eventually I can show you guys you can just use VS Code on your local machine and use a remote connection and do it through VS Code. But just for this I only need to change a few things, so let's just go ahead and do Nano. And we're going to edit that file. And in here, remember my setup is different, so we're going to go var LocalAI so that it points at that same models directory that we created earlier, so we're not re-downloading all those models every time we restart this. I'm going to go ahead and leave all of the rest of this, I think, stock, just like we did before. I'm going to hit Control-O to write out my changes, and then Control-X to exit. And then simply we're going to follow these instructions. Make LocalAI up. Make LocalAI up. We can see that at that time it actually started LocalAI, but it did it in the background. Now if we go back over, we should still be able to refresh and it should still be responding to us. Let's go ahead and select GPT-4 and have it write another poem for us. Write a poem about people who watch AI engineering videos on YouTube. So that brings us back here where I give you the ability to exec into that, or you could just see the log. So let's just go ahead and say make LocalAI logs, and this is just calling Docker commands to make it easy for you. And you can see that it printed out all the different logs of what we were doing, and it offloading that model to the GPU and loading it up. And then eventually it's going to respawn back to us. There it goes. Not too bad, right? Same thing, let's go make LocalAI exec. This is going to hop us on the LocalAI container, and let's just say like I can do an Nvidia SMI here just to verify that we're actually getting the GPU on the container, which we know because it was obviously running it through Inference. I can do exit here, and let's say I just want to turn that stack off now. Make LocalAI down. All right, that stopped it. And then the same thing, you could do restart too also. I hope you guys are learning something from all of this. Please feel free to go grab that code as an example, modify it to however you want. I think this is pretty good for a part 2. We've gotten quite a long ways in here. You have a fully running inference-based server that you can use from anywhere in your network now. If you like this type of content, let me know below. Give me a message down there, hit like. If you're new to the channel, I would love for you to subscribe and join us as we go through and do some crazy things with GPUs, AI, and LLMs in the lab. Otherwise, I will see you guys for a part 3. We are not done yet. We're going to keep going with all of this and get you guys all set up. Until next time, buy your AI a pizza. And you know what? It'd be nice if you bought me a pizza too. Just saying. See you guys next time. One more thing. On the premiere of part 1, when we were chatting about the reference of Ash, people kept saying, you know, Evil Dead. While I love that answer, aren't we missing the obvious one? Guys, Ash from Alien, you know, turns into where he's basically a robot that's artificial intelligence. But I'll see you guys next time.